First we're going to start with the definition of average rate of change. And the average rate of change is the overall distance traveled over the total time that it took to travel that distance. The formula is delta y over delta x, and the y values are your distances, the x values is your total time. And a good practical use for this would be like if you're going on a family vacation, like the Griswolds did. You could determine what your average speed was over the whole time of that trip.
Okay, so our first example is using average rate of change. We measured the height of the slide, which is 79 inches, and the length of the slide, and that is 120 inches, as shown. But we needed to find the actual slide length. So we used the Pythagorean theorem. A squared plus b squared equals c squared, and we got the actual side length equals 143.7 inches. So, 143. So then we need to find the formula, which is the change in y or the change in x. So we know that the time elapsed was 2 seconds. So that will go for the x, and it'll be 2 seconds minus 0. For the first one, it'll be 143.7 minus 0. And that comes out to be 71.85 inches. And that would be inches per second.
Calculus is fun! Woo!
Alright, so for example 2, you saw me swinging on the swing, and we measured the height. The height of my swing was 60 inches. And we measured from the center of the swing, and that went down, and the horizontal distance was 80 inches. Okay, and since the swing is a parabola swing through, that's going to add another 80 inches here. So I went a total horizontal distance of 160 inches. So once again, we use the Pythagorean theorem to figure out this distance. And after we did the Pythagorean theorem, 60 squared, 80 squared, turns out through here and here, I traveled about 100 inches. On both sides, times 2, 200 inches in all. The time total elapsed for me to go through the parabola of the swing was 2 seconds. Alright, so for the average rate of change equation, my total overall distance was 200 inches over 2 seconds. And this one's so easy you can almost do it in your head. You should be able to, rather. And so I was going about 100 inches per second. Cool.
Alright, so in example 3, we're going to be discussing instantaneous rate of change. So we rolled a pumpkin down a small slope, and we want to know what the instantaneous rate of a pumpkin is at exactly 3 seconds. So we did 27 feet, which is the height, and then over 6 seconds, which is the time it took from the pumpkin to get from the top of the slope to the bottom. And then 3 feet, there's your pumpkin, and that's 3 seconds. So you're probably going to want to use this equation, and you're using an x from both sides close to 3 seconds. And your h is going to equal 0.00001, which is a really minute distance from 0. Okay, now if Ms. Dollar, if you could pause this, and everyone try to do this.
Okay, so now we're going to find the instantaneous rate of change that this pumpkin had going down the hallway. I'm going to set that down. Alright, so our F here is going to be 4.5. Our X is 3 seconds, plus our H, which is a very minute distance, minus 4.5 again. All over 2 times H. And if you enter this in your calculator, you'll find that it is 4.5 feet per second. And this actually is the exact same as the average rate of change for this. And the closest reason we can find to explain that is the shape of the pumpkin. As it rolls, it does a lot of bouncing, and the hill, some of the tiles are a little uneven, so it's not always a constant acceleration. And the way the pumpkin kind of rolled around and lopsided as it went. It rolled this way, it rolled that way, and so the average also is the instantaneous. I mean, it's as close as you can get, simply because it's not a spherical object.